So what is the difference between push and pull? Well, let's say that your process can be represented by a sequence of jobs all connected together. And let's use this example of a chain of boxes, with each box being a job or a process step. Now in a push process, step 1 will always push its work to step 2, regardless if it's ready or not, and so on down the line. One takeaway from a push process is that usually everyone is busy. A bad thing, however, is that there's an imbalance in the system sometimes, and that's when work piles up and causes wait times, inventory, stockpiles, or other waste. So to represent this, remember we're pushing into the next step of that process, and every step is doing that. However, if so much stuff is being pushed into this process step, it will create additional inventory that can't be handled. And when the inventory can't be handled, it causes this impediment. That's the downfall of push. Now the pull process is when a customer demands the work when they want it from the previous process. Now this causes the process before that to demand the work and so on. So it's always pushing just in time. Now the benefit of a pull process is that it's virtually zero inventory, raw materials, and wasted work or product. But it also allows you to respond quickly to the customer needs. So every process has a limiting constraint or bottleneck. The theory of constraints, or TOC, is a tool to remove or improve the constraint. Let's review the steps of how to apply the TOC methodology. The first step is to identify the system's constraints. A constraint limits the process from achieving its goals or results. Step 2 is to decide how to exploit the system's constraint. We're going to decide how to improve the constraint so that it works to its full potential. In step 3, we're going to subordinate the rest of the decisions of step 2. And we're going to align the whole process to support the decisions made in the previous step. In step 4, we will elevate the system's constraint, and we'll consider further actions to resolve them. In step 5, if a constraint has been resolved in step 4, we'll then return to step 1 and repeat the steps to find the next constraint. Let's go through an example. So let's look at an example of theory of constraints. In this example, let's say that we're in a packaging process, and we have 3 sub-processes. The first sub-process is coding. The second sub-process is filling. And the third sub-process is sealing. Now the first thing that we have to do in order to do this is know its production. Well, currently, coding is producing 900 units per hour, while filling is producing 720 units per hour. And sealing is producing 780 units per hour. So how do we apply the theory of constraint methodology? Well, going back to step 1, we first off have to identify the constraint. And in this particular example, that constraint is filling. The second thing that we need to do is we need to assign the repair or maintenance to this. We need to identify why that's going wrong. So we're going to repair and assign our maintenance. Once we've assigned our maintenance and repair schedule, the next thing we have to do is we have to execute on that repair. We have to physically do it. So then step 3 is going to be to do the repair. Now once we've done the repair, that should remove this constraint. And then once we've removed the constraint, we're going to repeat that process to find the next restraint. Now this process, we went back and we remeasured it once we've had the constraint removed, and we realized that coating is still producing at 900 units per hour. That's not where the constraint was located. Remember, the constraint was located in filling. Well, since we've removed that impediment, we're now able to complete 840 units per hour. A huge improvement in productivity. And then with sealing, still doing its 780 units per hour. So by applying the theory of constraints and going through those 5 steps, we were able to improve our productivity in filling from 720 units per hour to 840 units per hour, thus improving flow from coating to filling to sealing. And that is the theory of constraints.